Oh no.
Welcome.
Oh, we didn't kill it.
No, we didn't kill any pigeons. No pigeons were hurt in the making of our last episode.
That a chicken die.
Yeah, unfortunate. All right, so last episode we said we're going to do a design proposal.
I don't want to do a design proposal.
Yeah, we're not doing that. So basically, design proposal, you'd fill out all the abstract and stuff, and then you'd submit it to management, and then they would approve you doing the project. Well,
I've approved it.
project approved. We're doing it. We're skipping that. So straight to the fun part.
Building stuff.
Yeah, we're making the prototype, and we've ordered some parts, and they've arrived. So it's time. We're gonna do some unboxing. This is not everything, obviously, because it's not that much, but it is enough for us to get started, and we're gonna get started. So let's open some of these suckers up.
So let's get these going.
Woo! Oh boy. You know, I didn't tell you what was in that, and it could be cuttable. So we should probably get a new one. Yeah.
No, we find because they put a box in a box. So.
It's a box in a box.
Oh, welding helmets.
Yeah. We got a welding helmet because we're gonna do some welding.
Thulium.
And Thulium, which is the cheapest of cheap welding helmets because we're not doing a lot of welding. All right, what else we got?
I guess I dropped my knife on this one. It's already open.
Already open.
Okay.
Yep. Got
Big
some
old bit.
big old drill bit. We got to drill some holes, put the bearings in. You can cut that up.
Okay.
Hub. This should attach the top of the shaft to our crossbar arm. Speaking of crossbar arm,
Crossbar.
we've got some old 8020 that I built a CNC machine out of, and we're gonna take it apart and use that for some parts. All right, let's see what we got here. Okay, this is our, this will read RPMs.
Oh, it reads the RPMs off the condenser. Gotcha.
That's pretty sharp.
I was kind of worried when I started that one.
Ooh,
okay.
wow. Okay.
Hope we didn't get anything that would. Okay. Big old shaft.
Yep, got a 1-inch shaft here. 1-inch
Shaft.
diameter shaft, but 12 inches long. We're gonna use that as the main shaft, spinning the arm.
Spinco bearings.
Yep.
Spinco.
Bingo. Not sponsored.
Okay, this one I'll probably break if I cut into it too hard.
Yeah, welcome. Very fragile. Oh yeah.
Okay, I didn't cut it. Because I'd hate to have to cut a 1-inch piece of steel. What's that, 10 by 10?
10 by 10, 1-inch steel plate.
About 30 pounds. Okay.
So we're gonna cut that up. Woo boy! I'll make the housing. And to make other frame parts, we got some other steel. Local scrapyard hooked us up.
About 50 pounds for 20 bucks.
It was a pretty legit scrapyard, like, you know, 2-story tall cars and metal piled up, and you're just walking around looking for stuff. It's cool.
There's probably, what, 300 DC motors all together?
Yeah, it felt like Junkyard Wars.
Yeah.
It was sick. But yeah.
But everything was already broken.
Yeah. There's a reason it was there. Yeah, unlike Junkyard Wars, was like a perfectly good working, like, why did they put this in the junkyard?
It's like, oh, it's a clean frame car. I could put wheels on it from something else and make it a car again.
It's like, what? We're continuing our opening. We've got more stuff that came in, and we're still working on stuff, but cold front came in. It's not too bad in the dusty garage, but
30 degrees.
it's a bit cold,
Outside.
especially for us. We're from Texas. But hey, let's keep opening, and then yeah, then we'll get to work. Woo boy.
I'll let you have the privilege today.
Oh.
The one thing that you like actually rip.
Okay.
Ah, fish scale.
So we got a fish scale.
We're going fishing.
So once we make the arm and it spins, what we're gonna do is we're gonna mount it in the housing with the shaft and the bearings and everything. And then we're gonna take our fish scale and we're gonna stick it to the edge of it and we're gonna pull it and see how much force it takes to spin it. We just need to do some calculations off of that, and that'll give us how much horsepower we need to get through the starting torque for our motor. So we haven't bought our motor yet because we don't know how much horsepower we need. It's gonna tell us. But we gotta build the frame first, measure how much it takes to get it started, and then boom. Okay, next, let's see what we got here. Watch my fingers. This thing's pretty sharp. You ain't gotta try too hard.
Agree.
Ta-da! Hard to tell what we're looking at here.
Skateboard bearings.
These are tiny rollers. There's a little bearing inside, and then this is like V-shaped. Let me grab a disc.
Definitely a U shape.
So the disc will go in the U like this, boop, and so they'll spin. We'll have four. Well, we have four of them. So we'll put one, boom, put one like here, 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 and then we'll have the motor spin it inside these rollers. That's how we're gonna get the RPMs on the disc. Last but not least, all right.
Okay.
Thanks, Amazon. That's a bit bigger of a box than it needed to be, but these are little shafts, and
Your little shaft.
the roller will go on the shaft, and then we'll make the housing. Boom. That's what we got. We'll start putting this stuff like on the table so you can really see it. All right, main drive shaft. The bottom of the main drive shaft will have a V-belt pulley. We'll have a V-belt go to another pulley for the motor. We don't pick that yet because we don't know the horsepower of the motor. Until we pick our motor, we don't want to pick the size of the pulleys because we may end up changing the size of them so that we can either speed up or slow down the RPMs of the motor to the main drive shaft. So main drive shaft is going to have a V-belt pulley at the bottom, and then it's going to have a radial ball bearing here. And then it's going to go up the housing. It's going to have another radial ball bearing here. And that's going to take all the radial force this way. Then after that, sitting on top of this ball bearing, this is a tapered roller bearing. It comes in two pieces. There's a housing at the bottom here. And then there's the actual tapered roller bearings. This is going to take the axial forces. So we can take force down on it like this. So we'll have this mounted right here. And to distribute the axial forces down, we'll have this collar. So this collar is going to be tightened onto this shaft. And so any weight pushing axially down on the shaft is going to sit on top of this tapered roller bearing, and it's going to take the axial weight. So the weight of the whole arm that's rotating. Now on top of that is that hub that we're currently mounting to the arm. And then this is the arm. So in between here, we're actually probably going to put a slip ring. So we need to get electrical power from the stationary housing to the rotating part of the arm. If you just stick a wire there, it's going to get all spun up. So we have a thing called a slip ring coming, and the slip ring can transfer the power from the stationary part to the rotating part. And that's how we're going to get power to the motor that spins the disc and the mechanism that releases the disc. This guy here, this measures RPMs. There's a little magnet right here. So we're going to mount the magnet probably to the V-belt roller here down at the bottom of the shaft. So as this spins, this magnet will go around. So as that magnet goes around, we'll mount this up underneath and it'll pass this sensor. Every time it passes this sensor, it'll count. And then this readout here, got a little control board in the back, will tell us how many RPMs we're getting from the shaft. So based on the RPMs from the shaft and the math of how long our release arm is, our swinging arm, that's going to tell us how fast we're throwing the disc. So that'll tell us the speed of the center of the disc. Right now we're doing the math of it's 4 feet. So there's a 2-foot radius from the center of this shaft to the center of the disc. And if this is spinning at 700 RPMs, then the disc is moving at 100 miles an hour. So we're currently designing it to where we can get the disc moving at 100 miles an hour. So once we figure out how much force it takes to spin the disc, then we're going to design, or we'll know which motor we can get. That motor will have a certain max RPMs. We'll go under that for safety, because that's the max RPMs without any load. Obviously, we're going to put a load on it. So we'll overshoot it a bit, but then we'll use pulleys to tone it down to where when it's maxed out, it's not going over 700 RPMs. That's where we're at. First, though, we're making the housing for all these. So these are 2 inches OD. So we're going to drill a slightly less than 2-inch diameter hole in those steel sheet blocks, and then we'll stack them on top of each other. But for the top and bottom stack, we need to drill through them with a 2-inch hole. These will stack in there, and then we'll do like an 1.5 inch hole or smaller so that the shaft to go through. But we need a 2-inch hole so we can mount these in. We're gonna drill that hole in a 1-inch thick plate steel, and then we're going to put these bearings outside because it's like 20 degrees outside, and we'll heat up the housing and we'll press it in. Oh yeah. Cutting the steel is going to be fun too, so we got to cut it into 4 pieces.
Basically anything with the steel.
Anything with the steel.
It's gonna be...
Yeah, we could have done aluminum, but we wanted to be a little sturdier. All right, so obviously this isn't everything, but it's enough to get us started.
Yeah, good to build something.
Let's do it. First things first. This buddy. Jeez. It's 1 solid block. We want it to be 4 smaller blocks. What we're gonna do, cut it in half twice, and we're gonna stack those 4 on top of each other, drill holes through it, and then that's gonna be the housing for, oh, watch your fingers, for the shaft. So that'll be the housing for the shaft where we put our bearings. The reason we're doing it in multiple pieces is because we don't have a CNC, a mill, or lathe, or we don't trust ourselves to cut precision holes in a 1 block piece of metal on both sides lined up perfectly with the shaft. So we're gonna cut it in like a pancake style so that we can, after we cut the holes, we can adjust the different layers to get the bearings lined up perfect with the shaft. Let's measure this perfectly in half, mark it, and then line it up with your saw and try to cut it. Yeah, close enough. All right, pretty good.
Okay.
We're gonna, it's pretty close.
Line it up.
It's a little off, but close enough. Let's bang, bang, cut them.
Bang, bang. Soul train.
You may end up wanting to wear the helmet, just so, because there's gonna be a lot of sparks. Yeah. We're about to have some sparks. Warning, please remove this protective film prior to use. Done. Woo boy, we're about to get some sparks flying now. All right, let's see if we can cut this 1-inch steel plate in half. Maybe let it cool down.
Take a while.
Yeah, maybe let it cool down.
Yeah.
We'll do this in waves. Hey, that's a substantial cut though.
I just don't know the
take...
limits of that saw either, so I wanted it to cool down.
Yeah.
I've never used it that long before. I've never used it more than like 30 seconds at a time.
Yeah, our cut ain't super straight, but that's okay.
Yeah, I saw that.
It's like pretty crooked. Yeah, it doesn't have to
you know
be,
what I mean?
It doesn't have to be perfect either, because like we're gonna pancake them. But yeah, it's definitely a bit crooked.
Wide away.
You got all the way through?
Yeah.
Holy shit, you're the best. There should be a DeWalt commercial. Is it designed to cut through 1-inch steel plate?
Yeah, right.
No.
Will it? I guess.
Probably. Oh. Oh, you're through.
Yeah, we're done.
I didn't realize you were through.
Only took an hour.
Perfect. Nice. Good cut. All right. Now just do it 2 more times.
All right.
But these will be easier.
Yeah, right.
Yeah.
I ain't touching it because it's hot.
Hot.
It's hot. 30 pounds of hot steel.
You're hot. Never stopped me.
From picking me up?
Yeah.
That'd be impressive.
All right. Cool.
That took what, like, how many hours did that take?
We kicked the breaker like 5 times.
Oh no, we kicked it more than 5.
We thought it was broken. Yeah, we thought we'd burn up your chop saw. Nice. Okay. It's scored. Now we're gonna drill a hole right on the edge of it. So the problem with the hole saw versus an annular saw is the annular saw has channels for the metal shavings to go up. The hole saw doesn't. The hole saw is like 1/10 the price. So we're gonna drill a hole straight through here so the shavings can fall through instead of just getting gunked up in the blades. That's the plan. See if it works. All right. So that is gonna catch all the metal shavings and drop it down the bottom. Ideally. We'll see. We're getting there. It's just gonna be a hot minute and we're gonna hope the blade holds up. Just gonna be real slow.